Then lastly, we come to example 3, which is given the graph of the exponential function. Let's see if we can write the equation. Now, this type of equation will be more challenging, I have to admit, than the other ones because of the fact that we're going to have to write our equation in this form. So it's going to be a times some base to the power of x minus h plus k. So there are literally 4 things that we have to find. We need to know what a is, what b is, what h is, and what k is. Also, unlike the other graphs we've done, h and k is not an actual point on the graph. So like for example, let me go back up here to our graph from example 1. H and k for this was -3 and 0. That was our h and k. -3, 0, 1, 2, 3 is right here. That was hk for this graph. It was this point on the asymptote that was kind of directly below that point, the -3, 3. So yeah, so it's not like I can just go, oh, here's the vertex, that's hk and whatever. I instead have to, usually what I do is I go to the asymptote and I look for kind of what the middle might be. Here's the thing though, you can get multiple answers that actually are the same, like when you simplify them. So some of you might choose to use this point as hk, some of you might choose to use that point as hk, either one is fine. Your equation would look different, but actually would simplify out to be the same. For this lesson, I'm gonna go ahead and use this point right here. It's on my asymptote. So that is one thing about hk. hk is a point on the asymptote, and it's got to be directly below one of the other points on the graph. Okay, so I had a point right here that was at 0, 1, and so I chose to put my hk directly below it. So that is going to have to be a choice, and I hope that you're comfortable making that choice. So I'm going to put my hk at 0, -2, which would make h 0 and k -2. So that could eliminate that variable and that variable, but you'll notice I still have 2 more I have to solve for, which is why I have like 2 other points in my graph so that I could figure out, actually I have 3 other points. I can use multiple points to find both a and b. So I'm going to start by first plugging in the h and k that I decided. So h is 0, k is -2. So I plug those in. So then that turns into a times b to the x minus 2. Now, I'm going to use this point to solve for a. The reason I choose this point is because this is where x is 0. I need x to be 0 to be able to find a, since I don't even know what b is yet. So what I'm going to do is I'm going to plug in 0 for x and 1 for y in my equation temporarily to see if I can find a. So I get 1 is equal to a times b to the power of 0 minus 2. B to the power of 0 equals 1. So I get 1 equals a times 1 and then minus 2. So then I would add 2 to the other side. So then I get 3. A is 3. Okay, so now here's what I have. Sorry, follow me down here. Now I have y equals 3 times b to the x and then minus 2. So this is what I have so far. Now I can go ahead and find b. And so to do that, I'm going to have to use one of the other points on the graph. And I think I'll use this one. This is where x is 1 and y is 7. So what I will do is I'll plug in 1 right there for x and 7 for y. And then I get 7 equals 3 times b to the power of 1 minus 2. So I'm going to add the 2 to the 7. I get 9. 9 equals 3 times b, because it was b to the first is b. So I divide by 3. So then b is also 3. So then I get, so now I know everything. I know a is 3, I know b is 3, and I have h and k as well from allowing it to be this point that was on the asymptote and directly below this point right here. Because remember, the reason that I realized I can do that is because that's where h and k always ends up. It always ends up directly below one of the points on our graph, but on the asymptote. Okay, so I now have all the things. I can put everything back together again. So my equation would now be, here's my a value, so that's 3. Here's my b value, and that's another 3. I'm raising that to the power of x, and then minusing 2. So here is one sample for the equation for this graph. I won't go into details about how, but maybe I'll just point out this a is to the first power and these bases match. So another possibility would be y equals 3 to the power of x plus 1 minus 2. If you wrote this equation, this would have been if h and k was -1, -2, and in that scenario, a is 1 and b is 3. That would have been if you had used this point, -1, -2. Yeah, so anyways, but these are actually the same thing. Like this is equal to this. It just depends on which point you chose originally for your HK. So that's the main thing. So just remember, HK has to be on the horizontal asymptote, so along this line. And it has to be directly below one of the other points on the graph. So I could have either chose that, which I did, and I got this equation, which is one correct version. Or I could have chosen that, and I would have gotten this version. I could have chosen this one. It's just, it would have been a little bit awkward because this is already part of the exponential growth, and usually HK is sort of right in the middle. But I could have used it and it could have worked. It would have given me some variation of this. So anyways, there's a couple of them for you to practice in the homework. And of course, I'll be there on Friday and I can answer any questions you might have.